Hello and welcome to the lecture series on 8051 microcontroller. So in this lecture, we will try to develop one program to generate 1 kilohertz square wave at the port 1 and pin 2 of port 1 using timer 0 in mode 1. So basically the question is to generate such type of square pulses and the frequency should be 1 kilohertz. So if that is the case, then the time period for the square wave will be 1 millisecond. 1 divided by 1 kilohertz will give you 1 millisecond. And consequently, for half of the time, it needs to be on, and for rest half of the time it should be off. So that means for 500 microseconds should be on, or it should be high at the output, while for the remaining 500 microseconds the output should be 0 at the pin 2 of port 1. So one count increment in register will take 1 microseconds. How we arrived at this result? So basically, a 8051 microcontroller uh, requires a crystal oscillator frequency of 12 megahertz, normally, which is used, although it could be different also, uh, but normally 12 megahertz frequency is required. So that is divided by 12 internally, and that is given to the timers. So for each pulse, for 12 pulses generated by the clock oscillator, we will get one pulse at the timer. Okay, so that's how we get 1 microsecond. So 12 divided by 12 is 1 megahertz, and if you convert it into time period, so that comes out to be 1 microseconds. So to generate, for our problem, you have to generate 500 microseconds of delay for on as well as off time. So we need to generate a count of 500. So for 1 microsecond, uh, one one count. So for 500 microsecond, the count will be 500. So 500 needs to be counted by the register of the timer, so that we get the desired delay for on as well as off period. For the before going into the calculations involved in the number that should be loaded in the register, remember 500 will not be loaded in the register, because the register is which is a timer, is not a down counter, it is an up counter. So it counts the values above. So if any number is stored in that register, a clock pulse will increase that number by 1. Okay, so we will look into it. Before that, let's look into two more registers, which are basically SFRs, which are used by the timer. So TMOD register is a timer mode register, and basically it consists of uh, two 4-bit. It's basically an 8-bit register, but it can be divided into two parts: the lower 4 bits and the higher 4 bits. Lower 4 bits is for timer 0, and the higher 4 bits are for timer 1. M0 and M1 basically decides the mode in which the operation should happen. So since in our problem it's given that we have to work in mode 1 and we have to take timer 0, so we need to configure this part of the tmod register. So this would be M1 should be 0 and M0 should be 1, so that we get mode 1. While here we should put it equal to 0 to get operation in timer mode. If it would be 1, then the timer would be operating in counter mode. So we need to put it 0. While this gate should be 0, because we are not interested in the in using external hardware interrupts, while rest of these pins, the bits need to be 0 because we aren't using the timer 1. So one more thing that need to be kept in mind is that TMOD register is not bit addressable. It is not bit addressable, so we need to uh, load the value in TMOD by way of byte operation. So we have M0 as 1, M1 as 0. So the total number that need to be put into the TMOD register for our particular problem will be 0 1 H. Now come to TCON register. So TCON register, the lower half, we are not interested in because it's for the interrupt operation. So the upper 4, again, we are not interested in TR1 and TF1 because they are used for timer 1. So TR0, it needs to be set in order to start the timer 0, and when there is an overflow, then TF0 flag, it is set. So let's proceed and see how we can calculate the number that needs to be loaded in the timer 0 register to obtain a delay of 500 microseconds. Okay, so the count that should be put in register is basically given by this formula. Count in register equals the maximum count minus the desired count plus 1. So the maximum count, since we are operating in mode 1, so in mode 1 counting is up to 2 to the power 16, so which is basically 65535. So this number should be 65535, and the desired count, we want to count 500, so we need to put 500 here plus 1. So you must be wondering how this formula came. So to understand this formula, let's take an example. Say I have an imaginary register which can count up to 10. The maximum value is 10, and I am interested in counting 5. So what should I put initially so that I can get a count of 5? So initially, say I'm putting 6. So when first pulse come, the 6 increments to 7, then the second pulse come, and the 7 gets incremented to 8, then the third pulse come, and this makes it 9. The 4 pulse come, this fourth pulse, it makes this 10, and the fifth pulse resets it to 0 0. So the 5 pulses corresponding to count 5 has been achieved if we put this the register value equal to 6, and the 6 is obtained if we put 10 here. 10 minus the desired count is 5, to 10 minus 5 is 5, and plus 1 is 6. So there's an analogy to understand how this formula came. Okay, so let's try to find out the value of that need to be put in our in the register for our problem. So the maximum count is FFH, and the desired count we have calculated is 500. So, it's in decimal plus 1, so we need to put convert it into one unit. Let's convert it into decimal. So this FF is basically 65535 and minus 500 plus 1, so 65036 in decimal, and if you can convert it into hex, you get FE0CH. So this value needs to be put into the timer 0 register so that we get the desired delay of 500 microseconds. 0C will be residing in the lower 8 bits of the 16-bit T0 register, and FE should reside in the upper TH0 register. Okay, so let's move to the program part. So I have already written the program here. So let's first understand how program operates, then we will run it. So basically we are in the first instruction we are clearing the second pin of port 1 to make it 0. Then we are using a call instruction and calling a delay, and that delay needs to be of 500 microseconds. So within this delay, when this delay is called, so tmod register, and I told you it's a byte, it should work on byte instructions since it is not a bit addressable. So 01 is loaded in tmod, and I told you that this 01 will ensure that timer 0 has been selected, and it operates in mode 1. Then the lower 8 bits of timer 0 is loaded with 0C, and higher 8 bits of timer 0 is loaded with FE. And then finally TCON is 10H. So 10H, it ensures that basically here we are turning on the timer. We are triggering the timer and starting the timer at this instant of the program. So it starts counting the up count, and we keep a track of the flag TF0, and this instruction basically checks whether TF0 has increased to 1 or not. So it will wait till TF0 becomes 1, and when it becomes 1, it moves forward and further, and it clears TR0, because we need to clear it, because otherwise timer 0 will again restart. Then TF0 has to be cleared again, so again to so that we can use the timer 0 register again and again. So then RET instruction is basically the return instruction, and so return now moves to the set B, this here. So the next instruction of a call delay. So when a call delay is again called, so before that set B basically makes the second pin of port 1 high. So earlier it was 0, then a delay of 500 microseconds, then it becomes high, then again a delay of 500 microseconds. So, and then SJMP mains, so this process repeats. So we get a square pulse which is having a frequency of 1 kilohertz. So now let's try to run this program. So I need to convert it into assembly mode, so no error. So let me put some breakpoints so that we observe what is happening. So let me put okay, let me first use this step. So if I press the first step here, okay, let me put it once more, click it once more. Okay, wait. So I've pressed the step button and it has evaluated the first instruction. So now we have P1.20, P1.2, this is 0. Now the next instruction will call the delay. So I am trying to put a breakpoint so that I may be able to locate what would be the status of various SFRs. So let me put it say at this point, okay. So then I'm putting step function. So please note that program register is now at 0002H. When I press a step, then it moves to here at this point, and then again I put the step button, press the step button. So tmod register has been set to 01. So tmod here is 01. Then again I press step. So now TL0 has been made 0C. Again step, and now TH0 is 0 FE.